Hi, I want to talk about image processing. So we have two sections of that for chapter 4 and chapter 5. And later on, when we learn more about the files, we're going to get into deeper of that one. So I'm going to start with chapter 4 first, and then we move on to chapter 5. So chapter 4 is talking about some basic filtering imaging and reconfiguration of the image, some basic stuff. So that's what we're going to start with. So before we do that, we just got to learn some binary stuff, and it's going to help a lot. Some of you might have it in different classes. Some of you may not have seen this before, but it is good to know about it. First of all, when we're talking about anything digital, that is digital image, digital video, digital sound, that's basically the data is saved as zeros and ones. In the future chapter, when we're learning about the files, we're actually going to dig into there and we're actually going to look at those zeros and ones. But for now, we're just going to use some tools to use them. Some basic stuff about the binary. So when we say binary, that means it's space 2. So when we say space 2, let's just start with our regular numbering system. So our regular numbering system or Arabic number or whatever you want to call it is base 10. Base 10 means I have numbers from 0 to 9 as a single digit. That's what we have. But we don't have a single digit as 10. So we go from 0 to 9. And when we add 1 to 9, we're going to shift to the left and then we add 1 to it. So 1, 0 in our regular numbering system is going to be 10. On the other side, when we're talking about binary, the binary is base 2. That means I start with the 0 and the maximum I can go is 1. So base 2 is never going to have a 2 as a digit, just like base 10 doesn't have 10 as a digit. So we start with 0 and then we go to that. So we have two numbers over here. So we have two digits for a binary and we have 10 digits for our regular number. Now, if we look at our regular numbering, you go back to elementary school, they were telling us early algebra. I don't know when you guys learned algebra. I taught it in the college to some students, which was interesting to me that the students graduating from high school still doesn't know the basic of these things. But anyway, going back to that, if I look at if I look at if I look at the number in a regular numbering system, 385, the way we calculate it is what? We take the 3, we multiply it by 10 to the power of 2, 10 to the power of 1, 10 to the power of 0. So we start from the right side, and then we multiply the first one by 1, then the next one by 10, then the next one by 100, then the next one by 1,000. So as we go to the left, we multiply it by 10. So that's the way we calculate. Now in binary, because it is base 2, we're going to use the same concept, but this time our base is going to be 2. So if I'm looking at the first digit over here, that's going to be 1 times 2 to the power of 2, then 2 to the power of 1, 2 to the 0. So if I just take one byte, which is going to be 8 bits, and I put it all together, so I start with 1, 2, 4, and that's basically 2 to the 0, 2 to the 1, 2 to the 2, and so on. So with one byte, if I put the 0, 0, 0 here, all the way to 1, 1, 1, 1, 1, I'm going to have a 255 combination. Of course, 255 is my last number, and but with 0, 0, 0, 0, I'm going to have 256. So the highest number I can have is 255. The lowest number I can have is a 0. So I can have a number between 0 and 255, which is going to give me a combination of 256, which is the 2 to the 9. Remember, this is 2 to the 8, 2 to the 7, and so on. 2 to the 0, 1, 2, 3, 4, 5, 6, 7. So if I go to 2 to the 8, I said it by mistake, 2 to the 8, that's going to be 256, which is the cell right here. So that's the basic binary, and you don't have to know all the detail of it, but it's good to know when you're writing program why things happen. Now, moving on to the so we are starting with the basic coloring. So when we talking about the intensity of your picture, we are talking about the number of pixels that you have. So when we say early on, what was that? The 2 megabyte picture that was 2 million pixel per picture. So that's the way we are looking at the pictures. So how many pixels do we have? So if we have more pixel and one of them is bad, then we cannot see it. Or if we want to make a very good color, then the more pixel that we have, the color is going to look nicer. And the other side of it is if I want to reduce or enlarge it, then the pixel can move around a little bit and still we don't see the difference. So the basic coloring of those pixels. So we have a picture that has pixels in it, and the pixel is going to have colors in it. So we're going to be working with the basic pictures in this class. To start with the basic, and then you can take it off to go anywhere you want to go. The basic coloring is 3 bytes. So we have 3 bytes, which are what? 8 bits each one of them. So that's going to be 24 bits. So we would have 8 for each one of them times 3. So we have 3 bytes times 8. That's going to give me 24 bits. But we don't have to worry about bits anymore. We're going to be talking about bytes now. So they call it RGB. That's red, green, and blue. So we have 3 bytes. Each one of them is going to represent one color. And remember I said that for one byte, you can have 0. So if I go back to the previous picture, so if I have 1 byte, I can have 0, all zeros, or all 1. So all 0 is going to give me 0, all 1 is going to give me 255. So these 3 bytes are going to tell me each pixel of a basic coloring is going to have 3 bytes. So each byte is going to represent one color. And the combination of that is going to give us so many colors. Of course, it's limited because it doesn't give us a lot of colors. So 255, 255, 255. If you multiply it by together, then you know how many colors you're going to get. Now, if I have all zeros, that means I have 3 zeros. Each byte is going to have 0. I don't have no color. That's going to be black. If I have 255 for all of them, that's going to have all the colors. You combine all of the colors, you're going to get white. Now, if I put, let's say, 0 here, 0 on the green, and then 255 for blue, that means what? I don't have no red, no green, I have blue. So 0, 0, 255 is going to give me blue. And 255, 0, 0 is going to give me red. 0, 255, 0 is going to give me green. And then we can mix it up. And your book has a chart of some of them that's available. Now, the key with this, of course, you can use the word of the color if you want to. So you can use the actual word red instead of 255, the 0, 0. But the good thing about this is if you're using the numbers, you can have shades of it. So for example, here we have 254, 254, 254. That's the black, but it's not, I'm sorry, 254, 254, 254 is a very little bit different white than the white that we have. We might not see it, and as we increasing the number, the color is going to change. So you can see the comparison between 00255 versus 00270. So we can actually write the program in the loop. We can just go change the color, going down, going up. So there's a big chart in there. Excuse me. So that's the basic coloring scheme. When we're going to be using the easy graphics here again because your book wants to make it a little easier to work with this. So we're going to be importing the easy graphic. We want the graphic image and graphics window. So we gotta have a file name. So we get the file name, we can get it from the user, or we can have it in a constant, or we want to do it. So we're gonna have a file name that's gonna create a graphic image. We're gonna create our window, a canvas, and we're gonna use the method called draw image of this object to draw the image. So if I do this, the file is going to display on my screen. Now, every picture has a width and height. It's a two-dimensional array. So we can go to every pixel, pick it up, do something about it. So remember, if I have a two-dimensional array or a table, my rows are going this way, my columns are going this way. So can you tell me if I want to look at this pixel? These are all pixels of a picture. So what is the row and column of this pixel over here? So we usually put the row first and the column after that. What is the row and column of this one? So it's a row 0, column 4. So the first thing that we want to do as a practice in your book is talking about how we can adjust the color of an image. So in this exercise in the book, it's taking a picture and it's going to make it the reverse. So it's going to take the colors and going to reverse. So we're going to go to every pixel in this picture. We're going to take the color and we're going to reverse it. So first we have to get the pixel. So remember what we had in the previous one, row 0 and column 4. So if I want to go there and I want to pick up this pixel, that would be my 0 and 4. We do have a method available to us in this package. And these are generally the same for a lot of graphic tools. So I believe we talked about this. When we have an object, we have two sets of methods, the getters and the setters. The getters are going to get the information. The setters are the one that's going to be setting something in there. So we go to 0 and 4. We have 3 bytes in it. And we're going to get the red, get green, get blue. So we're going to go to that pixel and we're going to pick up 3 bytes, and each one of them is going to have a color for it. So we're going to take the color that we have and we deduct it from 255. Remember, 255 was our maximum. So if we take the color and we deduct it from 255, it's going to be its reverse. Remember, these colors are going to be from 0 to 255. So I don't have to worry about going out of range. So we had a getter function. So we got these things. We modified the new variables. and we're going to put these things into the image again. So we're going to be using the set pixel as a setter. Again, we're going to go to the row 0, column 4, and we're going to put the new values in it. So how do we do this? We have some methods. We can get the width and the height from the image. Remember, we got the file name, we got the image. So when we got the image, we have the width and the height. So we're going to create 2 for loops, one going for the height, which is our rows, and one going for the column. So we're going to get each pixel, we're going to filter it, and we're going to put it back. So this part right here is a pseudocode. So if some of you guys are not very clear about what the pseudocode is, this is basically this part over here is the pseudocode. And of course, after all of these things, we have to save the file. So we are not gonna, we're gonna save it to another one. So the file name, we're gonna get the file name. We're gonna add the negative to the beginning of it. I'm gonna save it to this new file. So now I have 2 images. So we can do other things like flipping the image. So if I want to flip the image, it means what? If I have rows and column, I'm going to put this row over here. I'm going to put this row back here. So I'm going to go through these, and remember, I can make 2 copies. So that way I don't mess it up. And I can start from the bottom of the previous one and put this row on the top row of the new image. If I want to do it on the same image, I have to be careful, because if I write this one on the first row, my first row is already gone. So I don't have, I'm going to lose it. So it's a good idea to practice on the flip image. And there is a practice on the problem solving, and it has some steps of how to do problem solving. Take a look at it, go over it, and if you haven't done it yet, go do that. And that's basically what I have for chapter 4.